Hello, this is the first in a series of videos that reviews some algebra and calculus, as well as some fundamental mathematics concepts that are commonly used in engineering and the sciences. So the thing we want to talk about in this first series of videos is a little bit of a review of what a derivative means, and in order to review that, we need to understand the concept of the straight line and slope. So this is just a figure that illustrates a straight line with 2 points, x1, y1, and x2, y2. And you may recall it requires 2 points to define a line. And the slope is just defined as the change in y over the change in x. You may have referred to this in high school as the rise over the run, also known as vertical change over horizontal change. And what distinguishes or characterizes a straight line or a linear operation is that the rate of change is constant throughout the line. In other words, the slope is a constant. And so that's what describes a straight line. A line is increasing if it goes up from left to right, giving a positive slope. It's decreasing if it goes down from left to right, giving a negative slope. A horizontal line is defined to have a slope of 0 and is a constant function. In a vertical line, the slope is undefined. So if we have 2 points, x1, y1, and x2, y2, we can find the slope by taking the difference of the vertical points, y2 minus y1, divided by the difference of the horizontal points, x2 minus x1. And you can see that if x2 and x1 are the same point, that m becomes infinite, and so this is considered an undefined slope. So here's just an example of a linear function. Y is 3/2 x minus 1. When we have a line written this way, it's written in this form here. Y is mx plus k. You may have heard k referred to as b. That's not uncommon. M is known as the slope, and k is referred to as the y-intercept. In other words, it's the point on the y-axis at x equals 0 where the line crosses the y-axis. If we have a slope m of a line and a point, so we only know one point but we know the slope, then it's possible to find the equation of the line using point slope formula, and that's illustrated in this example where we would know y1 and we would know x1 and we would know m. Substituting for all three of those will eventually give us an equation. If we get a linear equation that looks like this one, then we can determine the slope. It's actually going to be minus a over b. And you can prove that to yourself by taking this equation, solving it for y, and looking then at what multiplies x. So two lines are parallel if and only if they're not the same line, and either their slopes are equal or they are both vertical and both have undefined slopes. Two lines are perpendicular if the product of their slopes is -1, or if one has a slope of 0 and the other has an undefined slope. The angle between minus 90 and 90 that a line makes with the x-axis is related to the slope through the tangent function. So the slope is basically the tangent of that angle, or the angle is the inverse tangent of the slope. So here are just some numerical examples. Here is a line with 2 points given by 2 and 8 and 3 and 20. So we can calculate the slope by using the previous formula, giving us a slope of 12. And then we can use the point slope form, and we could use the point slope form with either of these points. We're using it with 2 and 8. So 8 is substituted for y1, 2 is substituted for x1, 12 is substituted for the slope, giving us this equation: y is 12x minus 16. We can find the angle that that line makes by taking the inverse tangent of the slope, or the inverse tangent of 12, so that line is going to make an 85-degree angle. Another example, we have equation for two lines, and notice that both of these lines have a slope of -3. They're not the same line because they have different y-intercepts, so they're parallel lines. And then finally, if we look at these two equations here in the last statement, the first one has a slope of -3, the second one has a slope of 1/3. If we multiply those two items together, we find that these two lines are perpendicular. All right, so we want to define what a secant line is because the secant line um, leads us to the definition of a tangent line. So if you look at this circle in the figure, you see the green line and you notice that it intersects the circle in 2 points, and so a straight line is drawn between those 2 points. Now I want to point out that while secant is originally defined for a circle, a secant line can basically exist for any curve. So if we have a curve and we define 2 points and we draw a line between them, we've defined a secant line. Now, if we let those points get closer and closer together, so the 2 points on the secant line we let get closer and closer together until they become separated by an infinitesimally small amount so that they are essentially the same point, then what happens is the secant line and its slope basically will converge to a tangent line. So this illustrates a tangent line. The unique thing about a line that's tangent to a curve is it touches the curve in one point only. So the concept of slope is really important in differential calculus because basically the derivative, taking the derivative of a function, basically finds another function that gives the slope of that function at any point. So the derivative of a function is basically the slope of the line tangent at a point is the slope of the line tangent to the curve at the point. So it's equal to the rate of change of the function at any one point. So if we define slope as delta y over delta x, then we have the slope of a secant line to a curve. The secant between any 2 points is the line itself, but that's not the case for any other type of curve. So the slope of a secant intersecting y equal x squared at 0, 0, and 3, 9 is 3. And the slope of the tangent at x equals 3 halves is also 3. That's a consequence of something known as the mean value theorem. So let's see what the mean value theorem says. Basically, if you look at the figure, it's easiest to define from a figure. So here we have a secant line with a known slope, and we have 2 defined points that form 2 points on the secant line, a point here at A and a point here at B. So basically what the mean value theorem says is that somewhere between A and B, there is a point, we'll call it C, where the line tangent to that point has exactly the same slope as the slope of the secant line, and that this point C will lie somewhere between A and B on the open interval. So this is an extremely important theorem in real analysis. Okay, I'm going to stop the video at this point and we'll continue with a second video to complete our review of differentiation.